the African savanna and dry woodlands form one of the largest open ecosystems on Earth. This region contains seasonal grasslands, thorny shrubs, and patches of dry forest that stretch across wide areas and provide habitat for thousands of animal species. The structure of the ecosystem depends on a distinct wet-dry cycle, when water and vegetation shift quickly during different times of the year. During the wet season, temporary streams flow again, the soil holds moisture, and young grasses grow rapidly. The expansion of vegetation supplies energy that supports the reproduction and feeding activity of herbivores. The seasonal increase in prey stabilizes hunting patterns for multiple predator species. The ecosystem enters a period of growth driven by abundant nutrients. The long dry season produces a complete shift in the structure of the grasslands. Water points shrink, streams stop flowing, and the ground becomes harder. Vegetation dries out, loses nutritional value, and forces many species to travel farther to find water. The concentration of animals at remaining water sources increases competition and affects feeding behavior, defensive behavior, and predator range. The alternation between the two seasons creates the dominant rhythm that shapes the entire wildlife network. Large herbivores, small mammals, and predators adjust their activity to these seasonal changes. The savanna and dry woodlands remain a constantly shifting habitat where animals adapt to harsh climate conditions and unstable water cycles. The savanna woodland ecosystem maintains stability through predators positioned at the top of the food chain. Predators regulate herbivore populations, control small prey species, and contribute to vegetation balance. Each predator species operates with specific strategies that align with its body structure, habitat type, and active time of day. Lions, hyenas, leopards, and medium-sized predators form a complex interaction network that distributes energy throughout the ecosystem. When prey density changes due to seasonal patterns or climate variation, predator behavior shifts accordingly. This adaptive system allows the landscape to maintain natural balance through repeated wet-dry cycles. Lion groups rely on their social structure to optimize access to prey. They maintain positions on mounds, channel edges, or areas with suitable cover to observe the movement of antelope herds, African buffalo, and zebras. Lions use long-range vision and hearing to evaluate the movement pattern of prey before beginning their approach. During early morning and late afternoon, lower temperatures increase their active time. Female groups, which are the primary hunters, divide their positions in multiple directions. One group approaches from the upwind direction to reduce detection, while the other group moves along the outer edge to restrict the escape routes of the herd. When herbivores enter open ground, lions reduce the distance by moving low beneath the grass. They use natural gaps in the herd formation to select the launch point for the chase. If the hunt occurs near a water point, the chance of success increases because slippery ground reduces the speed of the prey. Lions target individuals that are isolated, older, or showing reduced physical condition. During dry periods, shrinking water sources gather multiple species in one location, increasing lion access to prey. However, long chases consume large amounts of energy, so the pride limits pursuit to distances under a few hundred meters. When a target becomes isolated, lions use powerful forelimb strength to hold and destabilize the prey. Against large animals such as African buffalo, multiple lions coordinate by gripping different positions to reduce the prey's resistance. Against antelope or zebras, they attack from the side to end the hunt quickly. Lion activity directly influences the behavior of many herbivore species. Movement routes, drinking times, and herd spacing patterns shift when lions are present. By regulating prey populations, lions function as a central element in the ecological dynamics of the savanna. Leopards depend on stealth and nearly silent movement to reach prey at close range. They are most active during early morning and late afternoon, when low light reduces prey awareness. Their spotted coat functions as natural camouflage within the patchy light of shrubs and scattered trees. Leopards often select elevated positions such as tree branches, rock outcrops, or large roots to observe prey before approaching. When moving, leopards keep their bodies low and use shrubs, shade, and natural paths to conceal their direction. They prioritize short bursts of speed rather than endurance. Their acceleration usually lasts from a few dozen to over 100 meters, so the starting point must be calculated precisely. Leopards focus on small and medium-sized prey such as impala, reedbuck, or young individuals of larger antelope species. When the distance closes quickly, they use strong hind limb force to pounce from behind or the side, causing the prey to lose balance. They then use neck strength and bite force to finish the attack. A defining trait of leopards is their ability to drag prey into trees. Strong limb muscles and curved claws allow them to lift carcasses heavier than their own body weight onto high branches. Reducing the chance of losing prey to hyenas or lions. This behavior gives them a major advantage, allowing multiple feeding sessions without constant defense. During the wet season, when vegetation becomes dense, leopards expand their activity into dry forests and thick shrub areas. Small prey such as young antelope, ground birds and rodents appear more frequently, providing stable feeding opportunities. Leopards regulate the abundance of small herbivores, helping maintain balance among grasses, shrubs, and other species. Their presence alters the movement routes of prey herds, creating seasonal patterns in animal distribution. Spotted hyenas operate within a matriarchal social structure in which adult females hold the central roles. This organizational system maintains order, divides food resources, and reduces conflict during hunting activity. Their ability to sustain high speed over long distances makes spotted hyenas some of the most persistent hunters in Africa. They use sensitive hearing and the ability to analyze scent to track prey across varied terrain, from open grasslands to dense thickets. Hyena clans expand their formation into a fan shape when searching for food. This movement pattern increases their field of detection and allows multiple individuals to monitor cues such as fresh tracks, faint sounds, or minor changes in herd behavior. When approaching prey, hyenas target individuals that are separated from the herd or show reduced physical condition. They apply continuous pressure by pushing the prey toward dense grass or uneven terrain where running speed is limited. Individuals in the clan take turns closing in to reduce the prey's ability to react. Spotted hyenas not only hunt directly, but also exploit opportunities. They monitor the activity of lions, leopards, and even medium-sized predators to access leftover food. Their ability to gather quickly through vocal signals allows them to gain numerical advantage in a short time. Hyena activity increases significantly at water points during nighttime and early morning. This is when many herbivores must approach water while being fatigued from daytime heat. Hyenas maintain a safe distance until an appropriate moment to initiate pursuit. One of their key ecological roles is the ability to consume hard tissues such as bone, tendon, and hide. Strong jaws combined with a specialized digestive system allow them to process most of a carcass that other predators cannot use. This activity reduces the accumulation of decaying material on the grasslands and lowers the risk of disease spread. Hyena clans organize feeding positions around a carcass according to a clear hierarchy. Large individuals access the tougher tissues, Younger individuals feed on softer parts that are easier to tear. Peripheral members maintain vigilance against threats from lions or leopards. In many situations, hyenas confront lions to compete for food resources. Although they are not as strong as lions, they possess advantages in numbers and persistence. When clan numbers are high, they can apply enough pressure to force lions away from the area. Spotted hyenas link multiple ecological layers within the savanna. Their presence causes herbivores to adjust travel routes. Lions to reconsider activity timing and scavenging birds to follow them to access remaining food. Through endurance and high adaptability, hyenas act as stabilizing agents in the food web of the ecosystem. Cheetahs are the fastest predators in Africa and use rapid acceleration to reach prey at close range. They maintain a low posture during the approach phase and use open terrain and short grass to stay concealed. Before accelerating, cheetahs observe the herd structure to identify an individual that is easiest to isolate. Their chases are short and focus on cutting the prey's running direction at turning points. A long tail helps them maintain balance during rapid directional changes. When the distance closes, cheetahs use a forelimb strike to shift the prey's center of gravity. Because they rely heavily on high speed, any fall can cause injury to the cheetah itself, so they avoid heavy impact whenever possible. After bringing the prey down, they quickly drag it to covered ground to avoid detection by hyenas or lions. During the wet season, taller grass reduces visibility and forces cheetahs to move into more open areas. During the dry season, broader visibility increases their hunting success. African wild dogs maintain a tightly coordinated pack structure with clear vocal and body communication signals. Their ability to sustain moderate speed over long distances gives them one of the highest hunting success rates among African predators. Wild dog packs surround prey through multiple small flanking groups. One group pressures the prey from behind, while other groups cut angles to force constant changes in direction. This strategy reduces the prey's ability to respond and increases exhaustion. Wild dogs rely on pack coordination rather than individual strength. When the prey slows down, multiple individuals close in to end the hunt quickly. Their large pack size helps them avoid direct conflict with other predators. During the wet season, when small animals increase in number, wild dog packs spread out to reach more hunting zones. During the dry season, they regroup into larger units to maximize endurance during long chases near water points. African wild dogs play a key role in regulating populations of small and medium-sized antelope. The stability of their packs reflects the overall health of the ecosystem, where food availability and environmental quality determine reproduction and movement capability. Medium-sized predators operate flexibly across grass layers, thornbush zones, and open woodlands. Their diversity in body size, limb structure, and sensory capability allows them to access prey that large predators cannot efficiently target. These species regulate populations of small and medium animals across wide areas. Caracals show strong adaptation to shrublands and low grass environments. Their developed hind limbs, flexible ankle joints, and compact body mass allow them to generate powerful vertical jumps during hunting. Their ability to leap straight upward to catch birds at takeoff is one of their most distinctive hunting strategies. Caracals approach targets by moving low through grass or by following the edges of large bushes. When they reach effective range, they jump vertically or at an angle depending on the prey's direction. This strategy reduces the need for long chases and improves energy efficiency. In dense shrub habitats, caracals rely on moments when prey cross intersections of animal trails. They use short distances combined with strong vertical force to launch surprise attacks. Caracals primarily target ground birds, hares, and medium-sized rodents. When bird density increases during the rainy season, caracals expand their activity into grasslands near water sources where birds gather to feed. During the dry season, they return to thicker shrub areas to hunt rodents that shelter underground. Servals are highly adapted to wet grasslands and areas with tall vegetation. Their long legs allow them to see over dense grass and create an advantage during curved downward leaps. Hearing is the primary hunting tool of this species. Servals rotate their ears independently to locate faint sounds from rodents under grass or inside shallow tunnels. When they identify a precise location, servals leap in a curved trajectory and use both forelimbs to pin the prey and prevent escape. Servals rely on timing and accuracy rather than long pursuit. This strategy is effective in habitats where tall grass limits visibility. When rains arrive and humidity increases, small animal numbers rise sharply, allowing servals to maintain high hunting frequency in wet lowlands. During the dry season, they shift toward thornbush areas or places with remaining groundwater where small prey gather to feed. Nile crocodiles are apex predators in water systems within grasslands and open woodlands. They distribute along channels, seasonal ponds, wetland depressions, and major rivers during high water. During the dry season, shrinking water levels create isolated pools. Crocodiles use deep mud to hide while exposing only their eyes and nostrils. They detect prey through water vibrations and slight pressure changes created by animal movement. At late dry season water points, ambush opportunities increase. Herbivores approach water while dehydrated and show reduced reaction speed, placing them within strike range. Crocodiles hold extremely close distances and attack only when success probability is high. During an attack, crocodiles use strong tail propulsion to surge from the water and bite the prey's leg or neck. Their powerful jaws maintain grip during the pull into deeper water. After subduing the prey, crocodiles perform rotational movements to tear portions of flesh. During the rainy season, rising water allows crocodiles to move widely through channels and flooded plains. Their seasonal diet includes fish, water birds, rodents, and small mammals along the banks. Crocodiles are key regulators in aquatic ecosystems. They maintain stable fish populations, control the movement of animals near shorelines, and support the energy flow between aquatic and terrestrial environments. African buffalo maintain large herds that move widely across the Savannah and form travel routes that persist through many generations. Each route reflects seasonal changes in grass cover and the location of major water sources. During the rainy season, when new grass grows thick and retains moisture, the herd expands its range, restores body condition, and enters a strong reproductive phase. During the extended dry season, shrinking water and aging grass with low nutritional value force the herd to retreat toward major rivers or depressions that still hold moisture. At these sites, animal density increases and resource competition becomes more intense. Buffalo herds pause to assess the surroundings. Adult individuals stand on the outer layer to observe, while younger animals remain protected in the center. When danger appears, several large individuals can turn back and form a barrier that allows the rest of the herd to move safely. This collective response forces major predators such as lions to choose timing carefully before approaching a large herd. Areas crossed by buffalo herds often retain short grass, allowing many small species to access food more easily. Paths created under the herd's movements become stable travel routes for warthogs, small antelope, and multiple ground bird species. During the rainy season, buffalo help prevent excessive shrub expansion, maintain open grassland structure, and preserve long sightlines. Which are important for most grazing species when detecting danger. African buffalo generates strong ecological pressure by maintaining low vegetation layers and creating movement rhythms that reflect environmental phases. Throughout the year. Their presence directly affects the distribution of predators and shapes the structure of many major savanna regions. Giraffes use a vegetation layer that most herbivores cannot reach. Their height allows them to feed on leaves, shoots, and flowers from trees such as acacia, redistributing browsing pressure and reducing competition on the lower grass layer. They move in small groups and constantly change feeding locations to avoid overusing any single tree cluster. Their long and flexible tongues enable them to handle thorned branches without injury. When drinking, giraffes must lower their bodies into a posture that reduces their ability to observe. Their vascular system regulates blood pressure to remain stable when the head changes elevation rapidly. Because of this limitation, giraffes select open water points where shrubs do not obstruct visibility. During the dry season, when grass quality declines, they rely more on drought-tolerant trees that retain leaves longer. The presence of giraffes influences the structure of upper tree layers. When they feed on upper branches, more sunlight reaches the lower layer, encouraging sapling growth and maintaining woodland diversity. Partially eaten branches become food sources for many smaller species. Giraffe digestion disperses seeds across large areas, supporting long-term stability of plant populations. When a giraffe changes speed or pauses to observe, nearby herbivores often react, creating a shared vigilance layer. This reaction makes giraffes an important ecological signal source for many species living in the same habitat. Impala are one of the most adaptable herbivores in savanna woodland ecosystems. They can shift their diet between new grass, leaves, and soft shoots, depending on environmental phases. This flexibility allows impala to persist across multiple habitats, from open grasslands to thickets. During the rainy season, impala focus on nutrient-rich young grass, while in the dry season they shift to low leaves that maintain stable nutritional value. Impala move in medium-sized herds that create an effective natural vigilance system. Individuals on the periphery elevate their observation levels and change positions frequently to detect danger. When threatened, impala use powerful vertical jumps that help them clear dense shrubs or increase distance before predators can close in. These jumps also act as visual signals that trigger defensive responses across nearby species. In regions with multiple water points, impala often select areas near woodland edges where tree cover and open grass combine to provide safe retreat routes. Feeding traces left by impala show clear seasonal changes in diet and reflect environmental pressure in each period. Due to their high adaptability, impala link several vegetation layers, from low grass to shrub plants. Hippopotamuses are closely tied to rivers and lakes, where water plays a central role in all daily activities. They remain submerged during most daylight hours to lower body temperature and prevent water loss. Their large body size and sensitive skin make continuous daytime activity on land difficult. At dusk, hippos leave the water and move to nearby grasslands to feed. Hippos feed mainly on short grasses that grow in moist soil. They follow fixed pathways from water to feeding grounds, creating distinct trails over time. These trails become shared movement routes for other species, such as small antelope, mongooses, and rodents. When hippos move in groups, they spread out across grasslands to reduce direct competition. Hippos strongly influence aquatic ecosystems through constant exchange of nutrients between land and water. While in water, their waste provides nutrients for fish and plankton. When they graze on land, nutrients from grasslands return to the river system through natural discharge. This cycle maintains energy flow in aquatic habitats, especially during the dry season, when water bodies become isolated into smaller pools. Zebras are among the most mobile herbivores in savanna ecosystems. They rely heavily on extensive grasslands and can travel long distances to find new feeding areas. During the dry season, zebras often lead migration movements, creating pathways through resource-poor regions before species like antelope and wildebeest follow. Their tolerance for limited food and water allows them to cope with strong seasonal variability. Zebras use herd structure to increase detection of predators. Adults on the perimeter frequently scan the environment using sight and hearing. When danger appears, the herd responds by scattering at angled directions, making it difficult for predators to isolate a target. Their strong body and steady running speed help zebras sustain long pursuits when chased. Zebras help maintain grassland structure by feeding on coarse upper grass layers, allowing new growth to emerge quickly. This feeding pattern combined with grazing from other herbivores creates natural stratification of the grass layer and supports high biodiversity in savanna ecosystems. Because of their role in migration and their ability to consume coarse vegetation, zebras are key contributors to grassland regeneration cycles in Africa. Mongooses move in small groups that often range from 5 to several dozen individuals. While foraging, some individuals act as sentinels to detect danger from a distance, while others search for insects, eggs, or small animals hidden under low grass. This division of roles reduces risk when the group crosses open terrain. Mongooses use a highly developed sense of smell to locate prey and can dig quickly to reach rodents hiding underground. In woodland habitats, small viverids such as civets are active at night. They mark territory using scent to reduce conflict between individuals. Their omnivorous diet includes insects, fallen fruit, and soft tissue from carrion, which contributes to natural decomposition and helps redistribute seeds across the area. The honey badger is a small carnivore with strong adaptability to diverse savanna and woodland conditions. It uses its powerful foreclaws to dig rapidly and uncover small reptiles, large insects, or rodents hidden beneath dry soil. Its digging ability gives it access to food sources that other predators cannot easily reach. Honey badgers travel widely and do not rely completely on surface water. During the rainy season, when insect numbers increase significantly, they expand their routes to take advantage of abundant prey. During the dry season, they use burrows, tree bases, or abandoned tunnels for shelter and temperature control. Honey badgers have fast, defensive and offensive reactions that allow them to maintain stability within the lower carnivore tier. They appear frequently in areas with high densities of small animals and help regulate populations of rodents and small reptiles. Their constant digging creates new soil cavities that become shelter for other species and help retain rainwater in sloped terrain. Vultures and other scavenger birds use high-altitude vision to detect carrion. They gather rapidly at carcasses and help remove organic material, reducing the spread of pathogens. This group is especially important during the dry season when natural mortality among herbivores increases. Topi antelope respond quickly to environmental changes. They often select slightly elevated terrain where wind carries scent signals from predators. Their ability to maintain high speed over long periods makes them one of the most effective natural alert species on the grassland. When topi change direction or pace, surrounding herbivores often adjust as well, creating a widespread vigilance pattern. During the rainy season, topi expand their feeding range into areas with new soft grass. As the dry season continues, they retreat toward long-lasting water points and maintain tighter group formation to reduce risk in depressions where visibility is limited. Small changes in topi behavior often serve as important cues for other species when assessing local safety. African savannas and woodlands function as a large interconnected system, where each species maintains a specific role within a seasonal cycle. Water movement from early rains through late dry periods determines herbivore migration routes, predator hunting schedules, and the distribution of birds, reptiles, and amphibians. Every small climate shift produces a chain reaction that spreads across the landscape. Large herbivore herds maintain grassland structure by shaping low vegetation. Medium-sized species and small groups regulate rodents and insects and slow the spread of shrubs. Top predators create ecological pressure across lower levels, helping maintain balance between prey and resources. At water points, the activity of hippos, crocodiles and water birds drives continuous exchange of material between land and aquatic zones. The survival of this environment depends on climate rhythm, water stability, and species diversity. This landscape remains a dynamic ecological system where every organism, from small to large, contributes to maintaining balance in one of Earth's most distinctive ecosystems.